video section, we're going to look at the laboratory that we discussed in the lecture part of the video, and this comes from Module 1, and it's measuring the wavelength of light, Module 1-1B. I'd like to show you the equipment first, and we're looking at a large ring stand. Mounted at the top of the ring stand is a diode laser, wavelength about 670 nanometers, passing through a diffraction grating, and there'll be a order of diffraction spots that we'll observe a bit later. But before we observe those spots, what I would like to do is look at the board and give you some idea of how this experiment will work to calculate the wavelength of light. Again, we have a diode laser that's passing through a diffraction grating, and you see there are several orders of diffraction spots. Some of the numbers we need to know is the distance from the grating to the pattern, the diffraction pattern, and then the distance from the center spot to the next spot on either side. Though you don't always have to go to the next spot, you can go to several spots down, and I'll show you how you would have to modify that number. That's going to give us an important angle that we need. We're going to call that angle theta, and that's determined by simply knowing again that distance L, and then by knowing the distance either from the center spot to the next spot or several spots down. Using the equation here, you'll be able to determine what theta is. Once that is done, we come up to the main expression that we need to be able to calculate the wavelength, and you'll see that stated here as well. M being the number of diffracted spots, either 1 or 2 or 3, depending on how far you want to go on either side of the pattern. D is the distance in the grating constant, and you'll pick either your grating will have a value or several values. We're using gratings that have several values. And again, M is the number of bright diffracted spots you're going to work with. It could be 1, it could be 2 or 3. If it's 2 or 3, then obviously this angle is going to change because you're going to come out to a different spot, and obviously that's going to change the value of X in your right triangle. Once you go through these measurements, then you will calculate out lambda, and you'll see how close it comes to the actual value of your diode that you'll need to know. This experiment works very well. It's based on Young's double slit experiment that is discussed in Module 1 in the course called the diffraction pattern that we had on the board. And you will see several diffraction spots, and we're going to view that from the central spot on either side of that central spot of the pattern. This being the central spot, and then we have diffraction spots that go in an equal number on each side of that central spot. And again, you can take your measurements of theta from the central spot to the spot on either side, or depending on what integer number you want to use, you can come off the central spot to maybe the 3rd, the 4th, the 5th, or 6th, depending on how many diffraction spots you have in the pattern.